Welcome to another episode of Codecast with Kieran. I'm your host, Kieran, and today we're diving into the fascinating world of Retrieval-Augmented Generation, or RAG for short. We're focusing specifically on a new framework known as FiGRet, which stands for Fine-Grained Guidance for Retrievers. This framework promises to tackle some long-standing issues we've encountered with large language models, especially when it comes to their reliability and accuracy.
Absolutely, Kieran. It's becoming increasingly clear that while large language models like GPT-4 have revolutionized how we interact with technology, they still struggle with something we call hallucinations. This is when these models generate information that may sound plausible, but is actually false or misleading. That's where RAG comes into play, as it seeks to ground the generation process in real, verifiable information by integrating external data sources.
Right? And the FiGRet framework takes this a step further. Traditionally, retrievers are trained using semantic similarity alone, which doesn't always align with the preferences of these LLMs. The authors of the paper propose a more nuanced approach by infusing feedback from LLMs into the training of retrievers, making the learning process more efficient and targeted. They draw from educational theories. Think of LLMs as teachers and retrievers as students, learning from their guidance.
I love that analogy. It really simplifies the concept. So, in essence, FiGRet operates in 4 key steps: establishing learning objectives, constructing guidance, training the student models, and assessing their performance. Let's dig into those learning objectives because they're particularly intriguing.
Exactly. The framework focuses on 3 main objectives: relevance, comprehensiveness, and purity. Relevance ensures that the retrieved documents directly answer the user queries. Comprehensiveness assesses the richness of information, and purity evaluates the noise level in the documents. By concentrating on these aspects, FiGRet aims to align the retriever more closely with the preferences of the LLM.
That's a compelling approach. So, how exactly do they operationalize these objectives?
Great question. They use the capabilities of LLMs to construct specific examples that serve as guidance. For instance, if a retriever performs poorly on a particular query, FiGRet can create examples that illustrate what a better retrieval looks like. This targeted feedback makes it easier for the retriever to learn and adapt, rather than relying solely on broad patterns across numerous documents.
And they implement something called dual curriculum learning, right? How does that work?
Yes, in dual curriculum learning, the training begins with simpler tasks and progressively increases in complexity. This is akin to teaching a child to walk before they can run. The idea is to build the retriever's confidence and capabilities incrementally, ensuring a solid foundation is established before tackling more challenging retrieval tasks. This method is shown to improve learning outcomes significantly.
Now let's talk results. The paper mentions that their experiments showcase improved performance across various tasks like language understanding and open domain question answering. It sounds like FiGRet isn't just theory, but it's yielding tangible benefits in real-world applications.
Absolutely. The authors demonstrated that by utilizing their framework, retrievers could effectively improve their performance metrics on standard benchmarks. What's fascinating is that they also point out the scalability of their method, achieving good results with a relatively small sample size compared to conventional methods.
That's impressive. Now, for listeners who might be developers or engineers in the RAG space, how can they apply these findings to their own systems?
Great question. For developers integrating RAG systems, adopting the principles of the FiGRet framework could enhance the performance of their retrievers without needing extensive re-engineering. They could implement feedback loops where their LLMs provide guidance on retrieval tasks and continuously refine the training of their retrieval models. This can lead to chatbots that are not only more accurate, but also more context-aware.
And looking ahead, what do you think the future holds for RAG systems and frameworks like FiGRet?
I believe we'll see even more integration between LLMs and retrieval systems. As models become more sophisticated, we may also start to see hybrid approaches that combine generative capabilities with retrieval in real time, resulting in chatbots that can handle even the most complex queries accurately and contextually. The field is ripe for innovation, and frameworks like FiGRet are leading the charge toward that future.
Well, this has been a thought provoking discussion. To summarize, we've explored the challenges of LLMs, particularly the hallucination issue, and how the FiGRet framework introduces an effective solution through fine grained guidance for retrievers. It reinforces the importance of relevance, comprehensiveness, and purity in RAG systems, ultimately enhancing the reliability of automated responses. Thank you for tuning in to Codecast with Kieran. We hope you found this episode enlightening, and we look forward to our next deep dive into the world of technology.
Thank you for joining us. Until next time, keep coding and stay curious.